So good morning. Our next lecture is analytic function. The complex function f of z is said to be analytic about a point z naught if it is differentiable at the point z naught and every point in some neighborhood about the point z naught. So analytic means it is differentiability. Is nothing but differentiability. F of z is function is analytic about the point z naught means it is differentiable at the point z naught and every point in some neighborhood about the point z naught, every point in some neighborhood, if there exists such neighborhood, then we call f of z is analytic. Otherwise don't call the f of z is analytic function. Suppose see here one example. 1 by z is one function. Let f of z equal to 1 by z. So 1 by z is complex function. It is not continuous at z equal to 0. If we put at z equal to 0, that will happen what by 0 equal to undefined. Okay, 1 by z is not continuous. So which is not continuous, it is not differentiable at the point z equal to 0. The function f of z equal to 1 by z is differentiable every point, differentiable every point in some neighborhood about the point z equal to 0, in neighborhood about the point z equal to 0, but not differentiable at the point z equal to 0. It is a differentiable every point in some neighborhood about the point z equal to 0, but not at z equal to 0. If it is z equal to 0 is differentiable, then we call f of z equal to 1 by z is analytic about the point z equal to 0. So but the function f of z equal to 1 by z is differentiable every point in some neighborhood about the point z equal to 0, but not at z equal to 0. It is fails to be at z equal to 0. Therefore f of z equal to 1 by z is not analytic function. Similarly, see here another example. So f of z equal to 1 by z minus 1 is also one function. Okay, is the function is the continuous at z equal to 1? Is not continuous at z equal to 1 because of, so denominator is 0 when we put z equal to 1. So therefore f of z is not continuous. It is not continuous at z equal to 1 means it is also not differentiable at z equal to 1. If it is failed to the continuity, it automatically fails to at the differentiability also. Okay, at z equal to 1 it is not continuous, not continuous, and also not differentiable. Okay, the function f of z equal to 1 by z minus 1 is differentiable every point, differentiable every point in some neighborhood about the point z equal to 1, but not z equal to 1. Okay, the function f of z equal to 1 by z minus 1 is differentiable every point in some neighborhood at z equal to 1, but not z equal to 1. It is fails to at z equal to 1 only, not in neighborhood. Therefore the function f of z equal to 1 by z is not analytic at z equal to 1. Other than z equal to 1, it is everywhere analytic. Other than z equal to 0, is the first one is everywhere analytic. See here, if any function, if any function is analytic, every function is analytic at every point in finite complex plane. The function f of z is analytic at every point, every point in finite complex plane, finite complex plane, then we call the function f of z is entire function. So entire function means the function is f of z every point in finite complex plane only. Okay, the function is entire function means it is analytic, analytic every point in finite complex plane, then we call the given function is called entire function. So see here one example, sin z. Sin z is complex function and function is trigonometric. So cos z and exponential function e power z. Okay, so these functions are entire functions. These are everywhere analytic, everywhere analytic in finite complex plane. At every point the function sin z, cos z, e power z and polynomials and etc, these all are continuous every point in a finite complex plane, then we call these functions are called the entire functions. Okay, see here clearly, a function f of z is said to be analytic at a point z0 if it is differentiable at the point z0 and also at each point in some neighborhood of the point z naught. Okay, at point z naught and in its neighborhood, then we call function is analytic. Okay, a function f of z is said to be analytic in domain D. In domain D means the function is analytic on D. On D means it is analytic every point in domain D. If it is fail at least one point, then we don't call is function is analytic in D. Okay, so analytic in domain D means it is analytic every point in domain D. A function f of z is also called a halomorphic function. Analyticity in another name, allomorphic function. Next, entire function. Entire functions are a function f of z is analytic at every point in finite complex plane. Function f of z is analytic every point in finite complex plane is called the entire function. See here examples: e power z, sin z, cos z, polynomials, etc. These functions are called the entire functions. Okay. See here one example: f of z equal to 1 by z, 1 by z at z not equal to 0. Okay, f of z is not differentiable. Why is not continuous at z equal to 0? It is not continuous means it implies is not differentiable at z equal to 0. So f of z equal to 1 by z is not differentiable only at z equal to 0, but other than 0 is differentiable everywhere. Hence f of z is not analytic at z equal to 0. So because of which is differentiability fails at z equal to 0 only. So other than z equal to 0, the function is analytic. Is differentiable. Is differentiable is analytic. Okay. So similarly, so in last we discussed f of z equal to 1 by z minus 1. Z minus 1. So in z minus 1 case, at z equal to 1 is different fails to the differentiability condition, differentiability property. So therefore is not analytic at z equal to 1 only. Other than z equal to 1 is everywhere analytic. Okay. Thank you.